Hello everyone. So in this session we will look structure elucidation by spectroscopy. So for that purpose you need to know you need to have some knowledge of NMR. So roughly or by summarily we will see only basics of an NMR which are required for problem solving. Whenever NMR it has been recorded, this is an NMR graph or NMR plot on which it has been recorded. Here you can see it has been calculated using internal standard, that is tetramethylsilane, and tetramethylsilane it is put on a scale 0, and from 0 it has been recorded further, and one of the unit that is ppm, and second unit that is intensity on a graph. So what kind of an intensity or each signal it will give. So whenever in case of an NMR, so here in this session we will be looking PMR, that is proton NMR, or it is also said H1 NMR. So in case of an H1 NMR, whenever the compounds or whenever a molecule it comes around 0, when the values are around 0, so this type of an protons, they are said to be an shielded type of an proton. So shield means it is having some covering, and that is why they are said to be an shielded type of an protons. And whenever the protons, when they shows the value in the downfield, they are said to be an de-shielded proton, means they are not having any covering, so they are said to be an de-shielded type of an protons. So as the electronegativity of an molecule increases, so whenever there is an attachment of an electronegative atom to a molecule, so it will carry a signal towards a downfield, and whenever it will be an electropositive, so it will carry a signal towards an upfield. After that, one needs to know what are the chemical shift values for types of an proton. In case of an H1 NMR, we just understand types of an proton and number of protons that can be calculated. So the first value, or the last we can say on the scale value, these are the delta values. So whatever we are looking over here, these are the delta values, and opposite to that it is tau value. So tau value, it starts from 10 and ends at 0. So here for tau value it will be 0, and at 9 position it will be 1, and corresponding respectively whatever the position it will acquire to 0, it will be 10 for tau values. So what in the problems we will be looking the values as per the delta values. So the highest delta value, it is for an carboxylic proton, so it comes around in the region of an 10. So depending on what type of an electronegative atom it is having, so it will show either shielding or de-shielding. Whenever electronegative atom it has been attached at this R with an alkyl substitution, alkyl when it has been substituted with an electronegative group, so it will be more de-shielded. And second one, proton, that is aldehydic proton, so it comes in the range of 9 delta ppm. One of the most important reason whenever we come across then pharmaceutical examples, we will come across the rings, and rings, they aromatic rings. So aromatic ring shows in the region of almost 7. So depending on what type of an electronegative or electropositive atom it has been attached, so it will show shielding or de-shielding. After that, alkene proton. So alkene proton, it comes in the region of an almost 5. After that, Y, so that Y, it is having an attachment of a nitrogen, oxygen or halogen. So such type of an protons, they will come in a region around 2.5 to 4.5. So depending on what type of an electronegative atom it is been attached. And here looking for an halogens, so there are 4 halogens. So fluorine, it will show always de-shielding, and whenever it comes to and bromine, it will show an shielding type of an effect. So here also same is the thing that depending on electronegativity type of an proton, it can be it will show the delta values. After that, OH and NH, these kind of an peaks, OH and NH peak, most often they are broad peaks. After that, hydrogen of an acetylene, it is showing the region of 1 to 2. After that, whenever Y, it has been substituted by carbon, oxygen and nitrogen having a double bond, so such kind of an protons, they come in a region of an 1 to almost 2.5. And after that, alkane. See, there is no need to mug up the readings or chemical shift. Just whenever you solve the problems, automatically it is been understood. So what type of protons it is. So for that purpose, you should have an habit to solve the problems. So automatically it will come. Now we'll see some examples how actually spectra looks, and after that we will come towards some problems. See, whenever so whenever recording of an spectra it has been done, so it will show some type of an signals. So signals, it starts from singlet, doublet, triplet and far on. So depending on the rule of n+1, so it will show type of an signal. So here for CH2, it is in green color, and signal, it is also in green color. So there are 4 signal. So it is quartet and 3 hydrogen for its and triplet. So how actually it comes? Signals will be recorded according to n+1 rule. So n, it is number of hydrogen on adjacent carbon atom. If we calculate now, we will look for an actually in quartet. So how it becomes an quartet? This signal becomes an quartet. See, it is also in green in color. So number of an hydrogen on adjacent carbon atom. So here it is having only adjacent carbon atom, this CS3. So number of an hydrogen atom on adjacent carbon atom, it is 3. So here we have taken n, value of n, that is 3 plus 1. So plus 1, so as per rule it is only m plus 1. So there is no need how much hydrogen does it have on its own. So we need to see only how much they are on adjacent. So here on adjacent it is 3. So we have taken 3n as an n, and so we get a signal that is quartet. After that, second signal. So second signal we get of an triplet. So it is of an this carbon atom, and so on adjacent to this carbon atom, it is having 2 hydrogens. So we have taken n2 and we get a signal triplet. So here it is a triplet. And how does we understand how much hydrogens they are on the carbon? So we understand through what area it has been occupied. So we will come across the examples where it is written actually in squares. Instead of number of hydrogen, it is given square, and instead of so by the ratio we can calculate number of hydrogen from this that squares. So in some datas you will find that squares are given. So squares are actually nowadays it is directly it has been calculated from an software, but in the earlier days this NMR spectrum, it was recorded on graph paper, and number of squares occupied by these signals, it was been recorded, and from that number of hydrogens it was been calculated. So area, how much it has been occupied, from that we get number of hydrogens. So here number of hydrogens are 2 and here number of hydrogens are 3. And now in this case, how protons they are being calculated. See here at 0 we has an TMS, tetramethylsilane. So the number of proton on tetramethylsilane, it is 12, and from that the value of this how much proton does this singlet has, that can be calculated. If we are considering it as an 12 TMS, so how much area it has been occupied by this signal, from that we can calculate for such kind of an protons, because there is no other protons to calculate in the ratio method. Now we will come towards an actual problems. Molecular formula, it can be identified by element detections method of carbon, hydrogen, nitrogen and halogen. So this is the problem. It is showing singlet with a delta value 2.20 and 3 hydrogens. B signal, it is singlet, delta value 4.02 and 2H. See, looking at the problem, here we need to apply lot many logics. How can be a structure and what are the signals. So from this singlet, it has been understood that adjacent proton, there is no adjacent proton on the, there is no adjacent hydrogen on the next carbon, adjacent carbon. So we will come towards firstly and this structural formula. See, there are 3 carbons and all are showing a singlet. All the signals are singlet. So what we will do, we will firstly draw these 3 carbon in a series. Why in a series? Because there will be no branching. We will see the examples of branching later on, but there is no branching because from this signal it has been understood that both the signals, they are apart from each other. They are not in the closer. They are not adjacent to each other. So from signal it can be understood that they are not adjacent to each other. So we will draw this firstly a series of carbon having a 4 hydrogen bond, having 4 bonds. Now coming towards a rule, that is n+1, and now if we apply for a signal, so n it should be 0 because it is giving only n singlet, and it means it is 0 that adjacent carbon does not have any type of an hydrogen. Right? Singlet, it means that there is no hydrogen on adjacent carbon atom. If we put a signal anywhere, we need to do this exercise that we have to apply the logics. So structure sometimes it may come correct, it may be wrong. We need to apply the logics. And this carbon, it is having 3 hydrogens. From this given problem, it has been understood that it is having a 3 hydrogens, or from given graph it has been understood that it is having a 3 hydrogens. So it means that carbon which is giving a singlet, it is having a substitution of 3 hydrogens. So let us put these 3 hydrogens on one carbon, and we have chosen the first carbon as already I explained that there is no hydrogen on the adjacent carbon atom, so we have chosen the first carbon. After that, B signal, going to the B signal, so it is showing a singlet of value 4.02 2H. It means that the carbon which is giving a singlet, so that singlet, it is having a substitution of 2 hydrogens. So let us place at last carbon, at third carbon I will say. So we have placed it. Now look towards this molecular formula. So 3 carbons they have been consumed and 5 hydrogens they have been consumed. So all the time whenever you will solve the problem, so see firstly towards a number of hydrogen atoms, whether they are matching with the problems or not. So here 3 plus 2 5, so 5 it is correct, and all the 5 they are been consumed now. Okay. And now remaining only there are 3 chlorine atoms and there are 3 vacant positions. So here you can see there are 3 vacant positions. Just put now the 3 chlorine on 3 vacant positions, and from this signal also you can understand that, see this signal, it is having a value of 2.20. So if you remember that we have seen for earlier the values of an halogen adjacent to an halogen. So this CH3, it is having little bit upfilled value, but this CH2, it is having a downfilled value, and the reason is it is having a substitution of an chlorine. As electronegative atom get attached to an carbon, so the value it will go towards an downfilled. Okay, now we will place the chlorine, and this is our final structure. Problem number 2, molecular formula C3H3Cl5. So the signals, they are triplet at delta value 4.52 1H and doublet delta value 6.07 2H. So from this signal, it has been understood that they are quite de-shielded, and number of hydrogens, they are correct. Here it is 3, so here it is also an 3. So firstly, we will draw a series of a carbon chain. If there is need, you need to also modify this carbon chain if needed. So firstly, we will try for this carbon chain. So from this carbon chain, carbon 3 now has been consumed. So these are 3 carbon, they have been consumed. So for now we will calculate the signal. See, for the signal A, triplet, it means that on adjacent carbon atom it is having 2 hydrogens, and 1, it is given in formula, and now the signal, it becomes a triplet. Now we'll try to place the hydrogen. So this triplet, it is having only 1 hydrogen, so we will place only 1 hydrogen. So let us place 1 hydrogen. Actually this structure, I know this structure, how it has been resolved, how it has to be resolved. So that is why I am writing this H. So at the initial moment you may write this H over here, but later on you will come to know that this structure, it will be not right as per the given data. So we will place H at the second carbon. You can place hydrogen at the first carbon also, but you need to match later on the data. If the data is correct and the structure is correct, then you can do it. Of course, I know the structure, that is why I am putting that hydrogen in the first position, second carbon. After that, next carbon, that is, it is showing that doublet. So doublet, it means that on adjacent carbon atom it is having 1 hydrogen, and so that is why we get a signal doublet. Okay, I will put a hydrogens of a doublet. See, this example, it is little bit confusing. You may have a doubt about it. So I have put the hydrogens on the 2 carbons. So why there is a need to put hydrogens on the carbon? Because I can put hydrogen on only 1 carbon also, but if you look towards a delta value, it is 6.07. So it is highly downfilled, or it is highly de-shielded type of an proton. So that is why I have put 2 hydrogens on the 2 carbons. If there might be only, I can put a hydrogen over here also, but I have not placed it because the delta value, it is 6.07. So the meaning of this thing is that it has been highly de-shielded and it is having an attachment of an electronegative atom. So from molecular formula, we know that there are some chlorine atoms so placed in this structure. So there are now 5 vacant positions and we are having 5 chlorine, and all these 3, they are been consumed. So at the first instant you may come across that you will put hydrogens on 1 carbon for a doublet, but it does not happen. From this delta value you should be able to understand. If the delta value, if it was certainly below 4.52, then it might be there. Then it might be possible that the carbon atom might have 2 hydrogens at the same time. But due to a delta value, I have placed hydrogens separately. Or you may also confuse why this doublet, it is not showing a different type of a doublet, or it is not recording one more C over here. See, these are equivalent protons. It might have recorded, but there should be an other substitution. Other than chlorine, 1 carbon should be substituted, and that is why it is equivalent proton. And equivalent proton will show always 1 signal, and that signal has to be bifurcated upon our understanding. And so this is the final structure of this compound. After that, problem number 3, number of carbon 4, hydrogen 9 and bromine. So one more electronegative atom. Doublet, signal of a doublet, delta value 1.04 with 6H. B, multiplet, delta value 1.95 with 1H. C, doublet with delta value 3.33 at 2H. If I draw a series with this of a carbon chain having a 4 carbon, as we have done in the earlier examples, drawing a structure firstly of a carbon. See, there is one clue in such kind of an examples. So what is that clue? So there cannot be 6 hydrogen on 1 carbon, right? So 6 hydrogen on 1 carbon, it means that there should be 2 carbons that are equivalent. And whenever we come to such type of signals, so there are 4 type of carbons over here, and these 4 type of carbons, out of that 2 are equivalent. So for 2 to be an equivalent, there cannot be such kind of an carbon chain. So there should be a branch. So whenever we see such kind of hydrogens, whenever it will be more than 3, it will be 4, it will be 6, or it will be 9. So assume that there are more number of carbon involved, more than one number of carbon it has been involved. Here from it can be understood, see this multiplet, it will be occupied by 1 carbon, say doublet, it can be occupied by 1 carbon, and now in case of a doublet, it has been occupied by 2 carbons. So from this molecular formula, it can be understood that 2 carbons, they are been occupied by this doublet. And number of hydrogens, so calculate number of hydrogens, they are 9. So this cannot be correct because from branching, so it has been branch structure, and that is why it is showing in multiplet. So we will come across what is actually resolving the structure. So 6H, it gives an hint that it is having CS3 branch. So whenever you will come across this type of an 6H or 4H or 9H, so you understand that it might be 2 carbons or it might be 3 carbon when it is a 9H. So let's draw the in this way. So it has been branched, these 2 carbons. Now we'll go towards a signal. So for the A signal, it is showing a doublet. So the meaning of doublet, it is that it is having 1 hydrogen on adjacent carbon atom. So actually doublet looks like this whenever we are recording an NMR spectrum. So let us now put the hydrogen on adjacent carbon atom, and this carbon, it will have 3 hydrogens. So 3 there are 4 bonds for a carbon, so 1 it is in between carbon, and remaining this 6 hydrogen we have to place now. So there are 2 carbons which are been engaged. So here it will come CS3 and CS3, and doublet, it means that on adjacent carbon it is having only 1 hydrogen. So from this we will now place only 1 hydrogen on adjacent carbon atom, and so there is no other position to place, as there is carbon bond. Now going towards an multiplet, here actually I have written 8 protons, so as per how much it is giving, so I have written it. But the multiplet, whenever we record a spectrum, this multiplet, it looks like this. It is not separated properly, and signals are not separated properly. Whenever there is doublet, triplet, quartet, quintet, so there are certain types of signals that has been shown, but in case of a multiplet, So signals, they are not proper, and that is why it is said to be a multiplet. But whenever this spectrum it has been recorded at higher hertz, around 800 or 400, so at that time we can separate such type of a multiplet. But whatever the signals over here they are been given, they are recorded on 60 hertz. So multiplet, it means it is having a multiple number of an hydrogen atoms on adjacent carbon atom, and so that is why it is giving a multiplet. So now let us place number of an hydrogen atoms on adjacent carbon atom. So here, as we discussed, that CH3 will come on this carbon. Now going towards the next signal, that is C. So adjacent carbon atom, it is having only one hydrogen. So for this C, we will consider last remaining carbon, and it is showing a doublet. So 1, it comes from this carbon. So here it is 1. And now see the multiplet. So number of hydrogen atoms, they are 8. So I have written 8 over here, and it is giving a multiplet type of a signal. So there are multiple number of an hydrogen atom on the adjacent. So now these 3 signals are accurate. Now going towards a molecular formula, these 4 carbons, they have been consumed, 9 hydrogens, 3 plus 3 6, 7 8 and 9, and remaining now only it is bromine, and there is only one vacant position, that is for bromine. So now structure, by placing in bromine we get the structure. Coming towards problem number 4, having a molecular formula C10 H14, A signal that is having delta value 1.30 9H, and B signal, it is having a singlet delta value 7.285H. From this delta values you get understand that what type of an protons they are. So now we will look for an B signal firstly. So from B signal it has been understood that there are it is actually an aromatic proton from the delta values. So it is around in the region of 7. So it is clearly indicating that it is an aromatic proton. And 5H, it means that it is an phenyl ring. Phenyl ring means what? It has been substituted. Benzene ring, it has been substituted at one position, and that is why it is having 5 hydrogens. There will be 6 hydrogen on benzene ring, but whenever it has been substituted, there will be only 5. So firstly we will draw a benzene ring. There are now 6 hydrogen, but as per the data given, it is having only 5 hydrogen. It means that it has been substituted. In case of an benzene ring, here it has been showing a singlet. In actual nowadays it is not showing a singlet for such kind of a ring. Either it is showing a multiplet or either it is showing a singlet, but this spectrum it is recorded on 60 hertz only, so that is why we get such kind of a signal. Now in advanced instrument you will get doublet of doublet, triplet of triplet, and such kind of signals you will get depending on what kind of substitution benzene ring is having. But here it is the data it is given, that is singlet. So 6 carbon they have been consumed and 5 hydrogens they have been consumed. So the remaining there are 9 hydrogens and 4 carbons. So earlier also I have told you that whenever there are 9 hydrogens or 6 hydrogens or 4 hydrogens, so it means that number of carbons they are more. So number of carbons they are more up to 6. When the number of hydrogens they are 9, it means that maximum carbon or minimum carbon they should be 3, and remaining now here we are having 4 carbons, but looking towards signal it is giving a singlet. It means that it is all the hydrogen atoms they are equivalent in nature, and equivalent in nature it means that all the hydrogens they are equivalent and they should be same So what we will do, we will place a carbon, and now signal for B, it is singlet. So singlet, it is giving that N, it should be 0, and that is why it is showing in singlet. Okay, this carbon should not have any type of an hydrogen, as the value of N, it is 0 and it is singlet, and there are 9 hydrogen. It means that it has been again a branch structure, right? So I have placed 3 hydrogen on each carbon, and now this compound, it will give this carbon, sorry, okay, not this carbon actually. So these are the carbons that will give us singlet, and we now looking towards the structure, you can see that 7.285H, so it is correct. And singlet, it is in a region of an alkane. So CH3, all CH3, all the 9 hydrogens, they are equivalent. That is why it is showing in singlet. So singlet, it is actually on this carbon, not on this carbon. It will not show any kind of a signal, as it is not having an hydrogen atom to an adjacent. Problem number 5. Again, same molecular formula, C10H14. Now looking towards a data, doublet at delta point 0.886H, multiplet 1.861H, doublet 2.452H, singlet delta 7.125H. Now looking towards this data, first assumption you might have drawn, that is, it is having an aromatic ring and it is having a 5 hydrogen. It means that it has been substituted with at one position. And earlier also we have seen such kind of an example having 6H. It means that minimum number of carbon here they are involved, they are 2, right? If we look now towards this multiplet and doublet, so one more clue here is that, see, this doublet, it is downfilled. It means that it is an benzylic proton. This benzylic proton, it shows in a region of almost 2.5 to 3.5. So depending on what kind of an substitution it is having further. So this benzylic proton, so from this doublet we get idea these are benzylic proton with 2H. So this carbon which is been substituted on benzene ring, it is having a 2 hydrogens. So these are benzylic proton. And further now we will look signal one by one. So firstly draw a benzene ring as per the D signal, and it is having 5 hydrogens, that is it has been substituted. Now we'll come towards an next signal, that is C signal. See, C signal, it is having 1 plus 1. 1, it means adjacent carbon having only 1 hydrogen. So adjacent should be this one, right? So from data it can be understood that adjacent it is having only 1. Now we'll place this CH2H2Y because here it is having 2 hydrogens, and now we'll draw the doublet, data for a doublet. So data for a doublet means this doublet, why it is giving doublet, because adjacent carbon atom having only 1 hydrogen, so it is giving a doublet. See, carbon is having now 4 bonds, right? So we will draw all these bonds. Okay, now coming towards A signal, that is it is showing a doublet, and doublet, it is branched one. So there are 6 protons. So we'll put this hydrogen on the carbon, and This carbon it shows an doublet. Now coming towards a last signal, that is D signal, B signal. See this B signal, it is showing an multiplet once again. Here I have written exact number of an number of an hydrogen on adjacent carbon atom. This carbon, it will show multiplet, and multiplet why? Because it is having an adjacent carbon atom. These are been having an hydrogen atom in multiple, so almost 8 hydrogens, so that is why it is showing an multiplet. Now coming towards problem number 6, C9H10 quintet delta 2.042H triplet delta 2.91 4H singlet 7.17 4H. So from this data it has been understood that singlet, it is for an benzene ring and in the region of 7.17 4H. It means that benzene ring, it has been substituted by at 2 positions. So now let us draw that 2 positions firstly. And why I have written actually 2 positions in the close, because if we come towards the next clue, so from this value you can understand that these are benzylic protons. So it is giving a triplet with 4H. It means that there are 2 carbons, they are been involved. When there are more than 3 hydrogens, so it means that there are 2 carbons been involved. So I have written them very close to each other. Now placing the carbons. Now placing the carbons. The signal for B, it is triplet. It means that adjacent carbon, it is having 2 hydrogens. So this is now only a remaining adjacent, right? And it is giving an quintet. So triplet and quintet. So now let us firstly place these hydrogen atoms and draw one more carbon atom. Okay, so I have placed these 4 hydrogen atoms as per the given signal, and it is showing a triplet. It means that adjacent carbon atom should have 2 carbons. So here, 2 hydrogens. So here are 2 hydrogens on the next carbon. Okay. So quintet means 5. So there are 4 on adjacent. N plus, here it is written opposite. 4 hydrogen on adjacent carbon, and we get a signal that is quintet. So from this data, if we look towards the data, singlet with 4H and aromatic ring, so it means it has been substituted by at 2 positions, and this benzylic protons, so they come in a region of 2.5 to 3.5. So from it has been understood that these benzylic protons, they are showing a triplet, and after that we get a quintet. Coming towards the problem number 7, C10H13Cl. So data given, that is singlet delta 1.576H. So from this it has been understood that it is having involvement of more than one carbon atom. So it should be either it should be a branched. After that singlet 3.072H. So it means that it is an benzylic proton. From the given data, it has been understood that these are benzylic protons. and after that singlet 7.27 delta value and 5H. So from this it has been understood that it is having an benzene ring. So benzene ring with one substitution as it is 5. Now we'll come towards the signal of an B, that is giving an singlet. It means that adjacent carbon does not have any type of an hydrogen. So now we'll put as here it is 2, so we have put 2 on that carbon. Now after that it means that it is showing a singlet that it should not have any type of an hydrogen atom on itself on the adjacent one. So there is no hydrogen atom now remaining, right? And from the signal A signal, we understood that it is branched, so I have written branched over here, and it is not having any adjacent hydrogen again. So CS3, and here it will be CS3, and adjacent will have no hydrogen atom. CS3, right? And after that it has been placed by in chlorine, because remaining we are only having now chlorine. See this 5 carbons, they are been consumed in the benzene ring or phenyl ring. After that carbon, we will say carbon, next carbon, remaining carbon, 4 carbons, they are being consumed over here, and 13 hydrogens. So 5 in this ring, and after that 6 over here, 11, and after that 2. And so remaining it was only an chlorine with one vacant position, so I have put a chlorine over here. So this will be the final structure of molecule. Problem number 8. C9H11Br. It is giving a quintet delta 2.152H. After that triplet 2.75 2H, triplet 3.38 2H, and singlet delta 7.22 5H. So from this data you can understand that substitution benzylic protons, these are benzylic proton 3.38 and 7.22 delta value, it means that these are aromatic protons having 5H. It means that it has been substituted at one position. So I will draw a benzene ring, and after that making it phenyl, and now benzylic. So now coming with a signal that is triplet. See this triplet, it means that adjacent number of an hydrogen, they are 2. So I have written, so I will write 2 hydrogen atom on the adjacent carbon atom. Okay, so I have written now signal. It can be, so signal for C, it is now correct that it is showing a triplet because adjacent is having a 2. So I have written over here. After that we will go for an A, that it is showing a quintet. So quintet means adjacent is having 4, and it will show a quintet. So firstly I will draw one more carbon. Okay, if I draw one more carbon placing 2 hydrogens, so it can show a quintet. So quintet with adjacent having 4 hydrogen atom placed. Now coming towards a molecular formula, and one more signal that has been remaining now till yet. So that is nothing but a triplet. So triplet, it means adjacent is having a 2. So this can be fit over here. The adjacent is having a 2. So now it can give a triplet. So coming towards a molecular formula, see molecular formula, 9 carbons, you can see that 6 carbon they are been consumed, 6 plus 3, 9 are been consumed totally, and after that 5 hydrogens over here and 6 hydrogens over here, CH2. So now remaining, it is only one vacant position on the carbon, as carbon has valency 4, and only one atom it has been remaining, that is bromine. Now you place that bromine over here. See, from the structure, from the given delta values, here you can see this quintet, it is upfilled, shielded proton. It is having a shielded protons, and but this triplet, it is having a de-shielded proton. Though it is at the end, but it is having an electronegative atom, right? And that is why the B signal, it is showing little bit values in the region of an 2.75. Problem number 9, C10H12. First signal, that is multiplet delta 0.652H, multiplet 0.812H, singlet 1.37, 3H, singlet 7.175H. See, from this, it is very well understood that it is having aromatic ring with 5H, means it has been substituted. Now going towards a signal of an C, see, it is showing an singlet. So singlet, it means that adjacent does not have any adjacent carbon does not have any type of an hydrogen placed on it. So I will draw. Okay, so this is how the structure it will be, and as adjacent is not having any type of an hydrogen, so I will not place anything over here. So let's see for a next signal how it can be. So I will put 2 hydrogens, and why I have written 2 carbons over here now, because if you look, so you need to apply the logics how it can be. So 5 carbons they have been 6 carbon they have been consumed. After that, here I have written firstly over here, after a substitution carbon or benzylic carbon, I can say. So there are no benzylic protons. From this data, it has been understood that there are no benzylic protons. And after that, one more carbon I have written next to it. So there are totally 8 carbons they have been consumed. There were remaining only 2, so I have placed over here 2. So you need to do such kind of an logics. You need to draw and rub the structures again and again to come towards a final structure. So I have placed bond in between. So let's see what happens. Now here are 2 signals actually. As per the data given, and as per my opinion, there should be a common signal for these 2, but this problem, it is according to the book, and the book has shown the multiplet and multiplet for these 2 signals. Both the protons are equivalent, but they are showing a multiplet. There should be only one common signal for these 2, but it is not, and it should, I think it should show a singlet, but it is not showing. So thank you. If you are having any doubt, you can put comments, and I will try to resolve it. So subscribe the channel, and for more videos, upcoming videos. So we will see some problems having a molecular structures, having an IR data, also having PMR and CMR data. So in the next some videos, I will cover that. So thank you once again.